I'm Dave Dugalman, the founder and CEO of EnterpriseWeb. Thanks to Rogers for hosting. It's nice to be up in Montreal and appreciate Tony arranging awesome weather for us. You probably all are having your insulin spike after having 2-3 cookies, so I'll try and keep this lively to keep you awake. So you've heard a lot of stuff at the radio level, and this won't be that, right? We're now talking about when Tony opened, he actually talked about the softwarization and AI and the emerging role for the RAN. So that's what we're going to focus on today, in particular, enabling CPU first AI for the RAN, and I think that's particularly important to actually enable like TCO, low TCO or an ROI at the RAN. So we're going to cover that. I'm going to start and present some slides, and then I have a demo that I'm going to start running about halfway through. And we'll present our solution to you. So this presentation, EnterpriseWeb, really quickly just set it up. Little or no marketing, hopefully. So EnterpriseWeb is an ontology-driven platform for intent-based orchestration. The ontology provides context as a service. Anybody who's following AI knows that context is the big buzzword. Of course, what is that? What's the context of the word context? Because context can mean a lot of things. It can mean state telemetry, it can mean models, it can mean lots of stuff. So our ontology serves context to optimize both LLM outputs, so very efficiently, low token, low latency, energy efficient communications with LLMs, as well as control agent behavior. Our approach helps with the ROI in GenAI, and by essentially reducing the token costs by essentially having a software optimization for LLMs, we don't need GPU, right? So we've been being told about tokenomics for the last 3-4 years. Oh, that is much easier. Thank you, Sebastian. I won't get that stiff neck later. You've been hearing about Jensen Huang and NVIDIA, and of course, what they do is great and fantastic and exciting. But the reality is this, most things just, GPU first everything is just not tenable, right? I mean, a rip and replace infrastructure is not tenable, right? The GPUs require more energy, they require more cooling, they're resource and energy inefficient. And so just throwing more and more tokens at something doesn't necessarily make outcomes better. And at the end of the day, you want better outcomes for your customers at the lowest possible TCO, right? And so we're talking about software optimization and providing a low TCO solution. And it's not a prejudice, right? I'm not saying CPU only. I'm saying CPU first, right? Because a lot of use cases, if you're doing inference, I mean, well, first of all, think of it this way. You guys have all been using AI, ML, and RL for decades. And in most use cases, actually, the closer you get to the radio, the faster, better, cheaper AI, ML, RL is for most use cases. It's only when you have fuzzy intents, right, that LLMs actually start having more value and being more interesting than sort of traditional Bayesian type models. So we can dynamically schedule between CPU and GPU, but the idea is actually overall providing something that's carrier grade, that's cost efficient, energy efficient, sustainable, et cetera. So we had done presentations with the IWPC on this topic before. We had won some awards with Dell, Intel, Red Hat, Fortinet, Keysight, sort of usual suspects, people that you all know. And we did testing in the what was Intel's Boston lab. I think they shut it down. And we tested on Dell hardware. Let me look back this way again, on Edge servers. And we were able to get 1,500 concurrent UEs on Dell Edge servers without acceleration, right, on these specs. And this is not state-of-the-art Intel either, right? So Intel Edge, Dell Edge box, Intel servers, 2x64, 2 terabytes of RAM. It's a nice, healthy box. But without our RCA and NetOps running, everything just got overwhelmed. The CPU couldn't handle the LLM, the presence of the LLM, and the token throughput. And then we did our software optimizations, and we were able to get a 75% latency reduction and an 84% energy reduction. And this is what I mean about sort of closing the performance gap with GPUs, right? GPUs are more powerful than CPUs. We know that. The question is, can I run LLMs on CPUs? Can I run them on smaller boxes at the edge and therefore enable AI at the edge? AI for RAN at the edge. And so this was about 18 months ago. And then these slides get distributed, and those links should be hot in the PDF. So you should be able to click through to the old research. But there was that benchmarking we had 4 different stages of it. Every one of them was documented in an 18-page document with like key site, all the performance data. Like it's pretty impressive. So the difference with this one we did with and actually part of what we did with that software optimization is we lowered the overhead of the solution stack relative to the telco use case, right? That's also really important, right? You start taking your traditional middleware stack, right? And that's a very chatty stack, right? Has lots of overhead. We do everything serverlessly, statelessly. So we're very lightweight, lean. And because we're low token, we're actually driving better performance out of the LLM as well. And I'll get into the details of low token. When I say low token, I mean not 30,000, not 50,000, not 500,000. I mean 3 or 4 tokens at a time. In a multi-turn transaction with an LLM, 3-4 times, 12 to 15 tokens total. Because our ontology, we put the ontology as the center of the architecture rather than the LLM. The LLM is not a proxy for a database. It's not a they're calling it an intelligence layer. It's like the least reliable intelligence layer ever, right? An ontology is deterministic. We use the ontology as a control language on top of the LLM, as opposed to GraphRag, which is essentially like a glorified document highlighter for an LLM, right? Chunking up documents, and you ship it out to the, loading up context windows and hoping the LLM picks out the right bits of context. We send 3-4 tokens that are all mapped back up to our ontology. When the LLM responds, we have to be able to validate it against the ontology. If the LLM's output can't map back to the context of the prompt we sent, we say try it again. We give it a little bit more context, but we're using the LLM for what it's really good at. It's not good at being precise. It's good at actually finding unmodeled patterns, right? Like we call that, if anybody's familiar with the database world and the SQL world, I know there are a couple at least, you have this thing called a wildcard search, right? Think of it as a wildcard inference. That's what an LLM is. That's its advantage over AI MLR. They're Bayesian, they are pre-modeled, right? They have all the advantages of that and deficits of it. But LLMs, they're a wild card, so use them as a wild card. Send them very precise information, get them to come back and say, oh, look, the other AI wouldn't have detected this because it wasn't in their model, but the LLM did, right? So there's a value proposition to using it. So we're going to be talking about saving CapEx by doing CPU and not GPU, no rip and replace, doing more with less, by doing low token, low latency, resource and energy efficient. We're optimizing the constrained hardware at the edge, right? Because it's constrained space. So we'll do more with less. And then AI for RAN. We're dynamically orchestrating the AI. We're rewriting the prompts and doing all these things like that to optimize the AI to optimize the network, right? Because otherwise, LLMs have inconsistent and unpredictable latencies. Since when has that been good in the network, right? I mean, you have all these characteristics of the LLMs that are just not particularly attractive. They're very powerful tools, but they're just a tool. They need to be a part of architecture that needs to be isolated and contained and leveraged for their best purpose, right? Like architecture we've always done. They are not magical black boxes. We should not look at them that way. That's dangerous thinking. So the use case is a secure edge gateway. We're going to manage that via agentic AI. This solution that you're going to see in the demo is already deployed in Snowflake on Snowpark containers. So we're using Snowflake to essentially host what would be a central knowledge and control plane for edge automation, so we can manage thousands of nodes. In that deployment, we're giving you a telecom ontology out of the box. So we have a harmonized standard-based telecom ontology. It has all the ORAN standards. It has all the 3GPP, TMF, ETSI, Tosca. It has the MCP protocol, the A2A protocol. It has all the agent-based protocols. It has open config in it right out of the box. It's a fully model ontology, things that take people 18, 24 months to try and do very tediously. We just give to the customer, and then the customer can extend it with their own model. So it's a pre-integrated solution that's leveraging Snowflake's rich data and analytic services, zero copy integration with Snowflake's AI data cloud, integration with Snowflake's Cortex, which is their LLM, integration with Snowflake machine learning algorithms and data science libraries, integration with semantic views out of the box. Like literally, we're a native app. You already have your warehouse there. Most of you do. You have your warehouse there. You literally say, I want this native app. It stands up as a cluster of pods. Whole solution is 50 megabytes, 50. It's running in minutes. Now, obviously, it has to be configured for purpose for you, but that's pretty cool. I'm talking about it's running, all the agents are running, it's connected to the LM, it's got NLP running, it's got MCP support, it's got all the things that you would want as a baseline. Boom, done. So this is what it looks like at a very high level. So this is to walk us into it. So you got the Snowflake services at the bottom, Snowflake containers. We lay into that with that ontology I described. And then we also put serverless functionality, a serverless middleware that goes along with that knowledge plane. And so you got a nice knowledge and control plane there that's meant for cloud native, serverless scale, resilience, all of those things. Out of the box, it's got the MCP for telco grade agentic AI. So there's a secure AI gateway there for you. NLP is ready to use as soon as you start using it. So an NLP interface is part of it. So you can talk to the network, you can talk to your agents, you can talk to Snowflake, your data in Snowflake. And then also it supports your external systems and agent clients. Yeah. So whether you work with ServiceNow or anybody, SAP, Salesforce, so we're bridging IT and OT. And then we sort of expose that to edge nodes over the network, right? Went into this. So these slides have more because I figure they get distributed. So if you like this topic, then there's more on these slides, and there's even additional slides. So we're going to do day 0. We're going to log in Enterprise Web that's deployed in Snowflake, and we're going to set up, going to compose a service declaratively with Linux Foundation's Aether SD-RAN, Fortinet Next Generation Firewall, Camalio IMS. We're going to order that service through an agent. We're going to map that service to specific edge node and 5G core and inventory. We're going to order that. We're going to bundle it with our edge orchestrator. If there's a third party, we actually are agnostic. If there's a third party orchestrator you already have deployed there, we'll just map to the existing one. So we're not opinionated in that regard. And then we're going to deploy our edge orchestrator, connect that to the resident LLM. In this demo, we're not pushing the LLM. The LLM is present. And in this case, it's mixtural. And then the agent is going to trigger a deployment workflow. Once it's ordered, we're going to deploy the secure edge gateway. All this is going to happen in the demo. Literally, this all happens in minutes. I almost have to give it to you this way because if we just run through it, it all happens almost instantaneously, right? So I want to tell you the system is actually doing it very methodically, very logically. Because it's an ontology, unlike an LLM, it's fully traceable, right? You can literally see every function. So it's like literally an ontology over your network topology of edge nodes in this case, over dependency graph. So we know every element of every service connected to every node, connected to every to the CAS, to the right. All of that is traceable through the ontology. You could do that as a human, but the agents also can walk that graph. This is pretty powerful stuff. And you can see then, that last bullet was you could see it in the AI data cloud. So very quickly, just graphically represent it. This is a little bit more detailed. We deploy the secure edge gateway. It was if I go back a second, if I can. Oh, sorry. Oh, never mind. I can't do it. So it deployed it and onto the existing CAS, connected to the existing SSLM, deployed all of those elements. It configured them, integrated them, right, assured them, does that in like a minute and a half, right? All done, full traceable. We're tracing down to the token count per interaction. You'll see 3 tokens, 4 tokens, 5 tokens. And then we can do closed loop observability over that. We could do that locally, so it's secure, low latency. And of course, we've been connecting back up to the control plane inside of Snowflake. So this is the demo. That's all for my slides. So hopefully that was a good setup. And let's
Thanks,
see.
Dave. Now I've got a lot to show, so let's go straight to the demo following the day 0, 1, and 2 outline that Dave had presented. For day 0, I'm going to log into a central instance of Enterprise Web deployed on Snowpark containers. This is our network manager module. You can see in this module a view of the service topology that's existing already. We can slice and dice it in any way we might want. If we want to look at it as just functions, let's just say. And we can, of course, narrow it to any domain we might want, any sort of edge site or region, all those kind of good things here. Gives us the visibility into the network itself and all the elements that are deployed. And similarly, if we want to use our service manager, we can actually take a look at the services that are deployed into that network. It's just a click away to get a look at the inventory that's been discovered there. We can see a 5G core. That's what we're going to be connecting our RAN to a little bit later. And if I were to pop into the Snowflake AI data cloud, you'll see the data is synchronized. After I stand up our new secure edge gateway, it'll also show up in this inventory. So back in Enterprise Web, in the Service Manager, we can compose new services from objects that are in our catalog or services in our inventory. We have about 300 objects in our catalog, and you can onboard new functions or even model new existing service endpoints to meet your needs. Let's click on one of the objects. Let's go into our Chameleon IMS. And what we'll see is that we have a complete model of the actual service. It was taken from, basically in this case, it was a zip file that had a bunch of information in terms of things like configuration files, scripts, image files, etc. And what happens is you upload them into the Enterprise Web System. It helps you map them to our ontology. And basically within an hour, you have an operating model that includes all the kinds of characteristics of the service itself, the application level models, things like, in this case, it'll be user planes and control planes, etc., all the component models, etc. It'll also map all the properties related to that particular component. In this case, it's an XNF. It'll generate a set of standards-based interfaces, and this is without code, so you don't have to write Python behind them or anything like that. It will give you a number of ways of actually being able to interact with the service element itself without you writing a line of code. And behind this, it will also generate for you a mapping to our telecom ontology, which shows you exactly how that particular, in this case, CNF, is mapped up to cloud native properties, the actual DUs and elements that will be deployed, lifecycle operations that it will automate, and so on, including in this case things like the wireless generations that it will this component will follow, so that it can map it to the right standards and glue it together when we get to service composition with the other elements that you might want in our service. Later on in the demo, we're actually going to take this IMS and compose it along with our RAN software to create our edge gateway. So now I'm going to compose a secure edge gateway. I can do this via Enterprise Web's API, GUI, or even the platform's NLP or an agent. You can use whichever you prefer for whatever task you're working with. And for rapid prototyping of a service, usually the platform's NLP interface is the easiest. I'll use that now. Later on in the demo, when I'm ordering the service, I'll come back and I'll use one of the Enterprise Web's agent interfaces. So I can jumpstart my new service by using a service template for common network service patterns and then customize them as necessary. That's what you're going to see me do right now as I have a simple conversation with the system. Show me a list of service templates.
Working on it.
Show me the graph of an edge gateway.
What RAN software do you want to use?
Use the Aether SD-RAN.
Do you want to specify a 5G core now, or do you want to defer that to the order?
Let's defer that to the order. Okay, add an IMS core to this, this service.
Working on it.
Add a firewall.
Working on it.
Okay, can I compose this?
Yes, all required elements are in the catalog.
Okay, compose the template.
Should I bundle an edge orchestrator now, or do you want to defer that to the order?
Yes, bundle the Enterprise Web Edge orchestrator.
Should I bundle observability now, or do you want to defer that to the order?
Yeah, bundle that now. Bundle Prometheus Grafana.
Should I bundle an LLM now, or do you want to defer that to the order?
Let's specify that at order time.
Do you want autonomous service management or humans in the loop?
Use humans in the loop.
To do this, I will create a new network service template named Secure Edge Gateway. Add an instance of EtherStack for RAN. Add an instance of FortiGate to provide the next-gen firewall. Add an instance of Camelio to provide the IMS. Bundle the Enterprise Web Edge Orchestrator. And bundle Prometheus, Grafana for observability. Would you like me to proceed?
Yes.
Working on it.
Okay, so just like that, the system was able to assemble for me the service. You saw the conversation specified the elements that we wanted. It combined them into a simple service graph, including the Edge orchestrator that's going to be part of that. It also puts together things like default properties for SLAs and so on. But what's most important here is besides the elements themselves, the system was able to generate for us day 1 and day 2 plans, right? So it was able to take what is really in our system, a high-level blueprint that it will then, so all deployments sort of follow a similar path, at least for network services. Then what we'll do is bind them to the specific elements that we just chose, right? So what in this kind of a case, what we're actually getting is something that will go through and generate K8 operators so that it can deploy all the components that we need, since they're mostly CNFs, or I think they're all CNFs. It'll instantiate our user and control plane. It's going to need firewalls and IMS, etc., right down to configuration. And similarly, it will also create for us a management plan that will go from observing an event stream, some kind of an issue that might have been actually present, violating an SLA, right through to determining what algorithms to use, even things like graph data science that are available in Snowflake. It will pull in, do pattern recognition, all those kinds of things, even query the connected LLM that we're going to choose at deploy time, and eventually even generate remediation plans and have us confirm them. So this is a pretty rich service already. We could even run it through DevSecOps testing if we wanted here, but we're not enforcing that. This for demo purposes, it'll make it go a little faster. But let's go ahead and add that to our catalog so that we can proceed. Okay, now we're on to day 1. Let's order our new service using Enterprise Web's ordering agent. First, we'll log in. Everything is secure, so you have to make sure that you provide your credentials so it can do its tracing and everything else. It has visibility into the services. So let's just look at what's there already. List services. So we can see that 5G core that we're going to connect to is already visible, and there's some other elements as well. We're going to go ahead and actually order a new service. So it has access to our catalog, and we can see there's only the one service in the catalog right now. Otherwise, we be presented with a list, but we're happy with that one. So let's go ahead and use that. So now it's prompting me to map to an edge node. We'll use the top one. Next thing we have to do is actually specify which 5G core. Again, it's looking at the inventory, and as we talked about at the beginning, and we saw just a moment ago, we want to use that 5G core, so we're happy with that. Otherwise, again, we could select from the list or even supply a new one if we wanted. It doesn't have a radio or base station. In this case, we actually want to simulate our traffic, so we'll go ahead and do that. It's asking me now to map to an LLM. If you remember at the beginning, we bundled the orchestrator. Well, now we need to make sure that we specify which LLM. We'll use Mixtral since it's already found that in the environment, and we're pretty happy. So just like that, our order is placed. This agent has now triggered the execution of the deployment workflow that I showed you earlier. It was configured by our choices to instantiate the instance. If we go back into the service manager that we were in before, and we take a look at the inventory, we'll see that service. In fact, actually, it's already up and healthy. The system has stood up a set of dashboards for us, so I can even go in and actually see the characteristics of the service itself. So this was that observability bundle that I put at the beginning when we created it. So let's just wait for the dashboard to load. So yeah, so you can see it's already consuming some energy. Everything's looking pretty good with the service itself. And we have a full trace that gives us all the details of what was actually done for that service order. So through the agent and MCP, an element level trace, everything from determining networks, ordering whatever subnets, instantiating all the elements that are going to be needed for the service, chaining them together. Everything is there in a nice, easy to look at inventory that gives us full trace and visibility into what was done for the service. And if I were to go back to Snowflake, and its inventory, we'll see that it's even synchronized here, right? We just refresh. We can see that our service has been added. Okay, let's move on to day 2. We stood up our service a moment ago, but we also stood up an instance of Enterprise Web's Edge Orchestrator, which is connected to a local LLM in that Edge site. The orchestrator also has an agent interface, which we're going to use right now. First, we're going to use it to query the health of our service. So let's log into that agent interface. So of course it has visibility. So what is the health of the Edge gateway? So all is good. There's nothing interesting at this point. But what I'm going to do is I'm going to spike traffic. If you remember, I configured this service for human in the loop so that our RCA and remediation will actually need approval. This way you'll get to see each step that the platform does. Otherwise, the fix would be pretty much instant. So I'm going to do that with a simple flood of traffic here. Just a second, I've got a little simulator. Let's bring it into focus. We're going to go ahead and start some traffic and see how the system reacts. So you can see that the system did two things. I mean, first of all, if you look at the back, you can see that the Grafana dashboard is lighting up as red. We're over all of our thresholds, and my agent at the edge is actually reporting that there's an issue. Right? It's giving me a summary at this point that performance is degraded, observability is configured, but AI ops need to actually be authorized to kick in. Activating those policies will probably fix the problem, but there's a full trace behind this that actually gives us all the details behind it, right? So how it came to this conclusion, etc. So let's actually examine that trace. So it's pretty lengthy here, but let's just start from the beginning, right? So it goes through an incident trigger, telemetry anomalies, right? So service spike in the instance degraded over 450% during the actual service state. Right, there's an SLA breach, power surges in relationship, basically determined that there was resource exhaustion, right? In this kind of a case, we actually need to go ahead and it's suspecting a DOS attack, which is pretty accurate. That's what we're doing with flooding. So at this point, it can actually go ahead and it can't do the remediation on its own because you need to actually authorize all the policies, right? So we'll walk down to the point of what the actual remediation plan is. So once we authorize those policies and we get the user consent, what we're going to end up with is rescanning to confirm that these are actually our issues, right? We'll look at the layout here and determine, in this case, CU, DU issue, what have you. What we get into is actually looking at the knowledge plane and management plane for our boundaries, specific SD profile failures, etc. And eventually it will come to the point where it will talk about executing an LLCM operation for scaling, and then it will monitor the recovery, right? So once we've walked through all of that, it's pretty lengthy, but if we want to go into that detail, it gives us, a point-by-point, breakdown of, what the problems actually were, how it's going to fix it. You can see this is all, to remind you, this is all being run CPU first on that edge network. There's no GPU involved. It's using a low-power LLM, and it's really using the power of what's behind Enterprise Web to make these kinds of determinations. So we'll go ahead and actually authorize those policies. So right away, what we actually get is the system fixing the problem, right? You can see in the background, we're already back down to low power consumption, latency that's good. If we go back into the service manager itself, what we can actually see, if we refresh here, we'll see that the interaction with the agent actually was occurring, right? This is all being centrally managed, right? That edge node is reporting back to our centralized Snowflake inventory and control plane, with what the details are of those local operations. So you get the benefit of local processing in the edge node and sort of centralized reporting, et cetera, and visibility. I can actually look at the events that are being, in this case, running. You can see that there are some scale in and out operations that are going on. It's even reconfiguring our firewall. What the impacts are of each one of these operations. So really what we did when we authorized that was a sort of continuous remediation or optimization of that service. And you can see it's really using only a handful of tokens every time. Our impacts on latency and power are pretty good here. And again, it's going to be constantly running. If we want to drill into the lower level detail, we always can. We can look for things like what algorithms it ran. And again, GC, in this case, a graph data science algorithm to predict no impacts. We can see that there was a prediction that was actually associated with this, and even right down to the point of what the remediations actually were, right? In this case, they even extended out to, in this case, it's even optimizing our IMS that's connected, right? So all the different elements, and of course, traces on low-level token consumption, et cetera, but gives you the full story of what this service is doing sort of across the board. And then one more cool feature I want to show you, right? is that if we go back to Snowflake, right, so let's go back into Snowflake, what we did was we actually used a service that they feature called semantic views. We pre-integrated with it so that we were able to basically, in this case, have the activity of our agent that's being fed back to the Snowflake AI data cloud be something that we can query directly, right? So what I mean by that is I can go into their AI dashboard here. They have something called an analyst. So our system created this agent impact semantic view. Basically, what this allows you to do in Snowflake is actually ask questions through their LLM about the agent's performance and impacts that it has, not just the network service health. So I can say things like, what is the average impact per operation by the agent? It'll take a second here, but what it does is it does a grounded text to SQL generation for us. So it's able to actually go in and see that on average, every operation is saving us this much improving latency by this much for power, and so on. So that's the end of my demo. Hopefully that gave you a good idea of the power of our CPU FIRST Edge AI orchestrator and the power of our platform overall. Back to you, Dave.
All right, so I hope that was interesting. And so any questions? That's it for the demo. I wanted to present that as something that's in the realm of the possible. A couple of things that I want to point out is, first, with our use of the ontology over the LM or SLM, it could be a trained LM as well. So first of all, we've never trained Cortex. So all that action, we never trained Grant. We've worked with Grant. We're Red Hat, Intel, we're partners with everybody, right? We've never trained a language model. Think of it this way. If you guys are all experts in a field, you ask less questions because you know. And when you ask questions, you ask very targeted. I've been hearing them, right? You ask very specific questions because you know. And the person you're talking to also knows your context is already shared, right? So you can drill down, in effect, with very few tokens in a conversation in the IWPC because you're all experts. Well, now, an ontology is literally a model of domain expertise. That's what an ontology is. And so the ontology models the domain expertise, allows that low token. And another thing to note is LLMs are serial processors. When you're sending 30, 50, 100,000, 250,000 tokens, the reasons why your latencies are inconsistent and unpredictable is because it's queuing, right? When you're sending 2 to 3 tokens at a time, 4 tokens at a time, you're never queuing, right? That's why nothing was clipped there, right? Everything was the time it took that it happened. So this is our platform and our capabilities are deployed with tier ones. We're partners with Snowflake. Sridhar is going to come up here. I'm Sridhar's warm-up act. He's going to get into the technical stuff. I'm just a software guy. And so any questions?
Questions for Dave. Hey, Dave, so same question to everybody. What do you need from these guys? Wish list.
God, with Snowflake, we're happy just to do pilots, and of course we learn from them too. And everybody has a different environment, different initiatives and interests, right? So they don't all deploy it the same way. So we can learn from that, tune it for their own benefit, and that's it. So I think like a lot of people that are like the telcos themselves, they're getting experiences now, right, with AI and agents and all those things like that. And now we're hopefully an enabler and an accelerator for those experiences, and giving them something, lightweight, horizontally architected. It's effectively a 6G architecture, right? It's semantic, it's event-driven, it's AI-powered, right? It's horizontally architected. So it's an out-of-the-box 6G architecture. So yeah, I think for us, we have 5, 6 pilots we're talking to with our friends at Snowflake, plus our existing deployments. So we're pushing these boundaries hard.
Mainly in the US, or?
No, not just globally, tier 1 and tier 2. And we've been deployed in tier 1 environments for 7 years, 8 years. Never crashed in production, not one. Of course, it wasn't 7, 8 years ago. It was an LM, but it was already ontology driven. We already have agents in our system, so it was the same characteristics.
Okay. Any questions? All right, let's give a big round of applause. Thanks, Dave.